Greetings and welcome to week 4. This week, you only have one assignment for reading. It's just read chapter 4, repetition structures. Straightforward, simple enough. We also have the lab, and that's all your assignments for this week. But the lab is a little more intense than the prior ones have been, so you do want to budget your time accordingly this week. You'll have 3 programs to write in addition to the 21 checkpoint questions. So again, Lab 4, recap of last week, which was Chapter 3, Decision Structures. You're going to go through the checkpoints, questions 1 through 21. We are going to skip the turtle graphic stuff again this week. Answer all those, throw those in a Word document like you have been doing, upload those with these 3 Python programs. The first one is exercise 11 from your textbook. Again, we're talking Chapter 3. Simple if statements, basically. What I do want to encourage you is to please follow all the software requirements. There's a few more this week. So again, we're going to use comments everywhere. I want your name. I want your name of the program and a description of what it's doing in your words. I want you to throw comments out there every time you have something stored in a variable. I don't care if that's a regular variable or a named constant. Remember, named constants have to be in capitals too. That is pretty much the industry standard across a multitude of languages. Declare and initialize all your variables. You're going to use a variable in this program. You are going to declare it at the top. We'll see some examples of that today. Comment the meaning of all your variables as they're created. Anything that you need to calculate, that goes into a variable as well. Any input that you ask of the user, make sure it's user-friendly. Make sure it's got spaces at the end so things aren't running together. Make sure you have correct grammar. Format all your numerical output in some appropriate format that makes sense. And I'll kind of indicate that as I go through these really quickly. And then use the decision statements that we learned about in Chapter 3. There are multiple ways of doing some of these tasks. I'm looking specifically for you to practice with if, else if, and else statements. As we talked about in the week 3 video, review that video if you need some refresher. So, Exercise 11 asks you to basically figure out how many points in a club that a user would get for buying a certain number of books from this particular bookstore. There's a little more detail in the book, but effectively, the user should input the number of books they bought. And you use the scale that is in the textbook, again in Exercise 11. To figure out how many bonus points they earn on their in their account. In this case, the formatting of your output, you're taking an integer, and the table, as you will see, is only integer values. That would be an ideal way of doing this. Now, there is an important change here I would like you to note from what the instructions are in the book. The book very specifically says if you purchase 2 books, you get whatever number of points. I believe it's 5. They don't have point values set for 3, 5, or 7. The way it's written, it implies that you only get points if you buy 2, 4, 6, or 8 books, or more than 8 books. However, let's use these inclusive. So if you buy 2 to 3 books, you get the 5 points. If you buy 4 or 5 books, you get the next level. If you buy 6 or 7, you get the next level. Okay. If you got any questions, email me. The next one will be exercise 13, shipping charges. Again, something very similar. The requirements are pretty much the same. We're using if, else, if, and else statements. This one works with the weight of a package and calculating the shipping rate based on that rate. Shipping rate is dollars and cents. I would expect to see dollar signs. I would expect to see 2 decimal places. The weight of your package, let's say we round that to 2 or 3 decimal places. That seems to be fairly normal. Okay. If you wanted to do 1 decimal place, I suppose we can do that as well. But make sure output is formatted accordingly. So again, you're going to enter the weight of the package. It's going to calculate which shipping rate you have based on that rate, and then you need the total shipping charges, which will be that rate times whatever the weight of the package is that the user initially inputted. Lastly, you have a larger program that does a little more with ifs and some nested ifs. And this one is determining Hot dogs for a picnic. Basically, there are 10 hot dogs to a package. There are 8 buns to a package. Your program should input how many people are coming to your picnic and how many hot dogs each person is entitled to, and then do the math accordingly to figure out how many packages you will need and how many packages of hot dogs, and how many packages of buns you will need, and then how many you'll have left over as well. Unlike the recipe, where some of you decided to make batches or half batches, we're looking for exact numbers in this one. How many packages you need to buy, and then how many will you have left over. Those should be clues as to what mathematical operators you will need to do the math part of that. Again, any questions, feel free to ask. We are talking about whole numbers of hot dogs and buns and whole numbers of people coming to our parties. So format your output accordingly. Lastly, the submission. You should have 4 things you're submitting for Lab 4 on Sunday. There should be your Word document with all of your checkpoint questions. I will modify that. That should be Chapter 4. You will have 4 different Python files. They should be valid Python files, simply statements. Please test them before you submit them to make sure there are no syntax errors in them. Make sure they run. And lastly, I'm going to be a stickler on this. Please name them accordingly as these say. Lab 4 Part 2, Part 3, and Part 4 respectively, .py. That's it. That's your assignments for week 4. Let's get into our lecture here. We're going to talk about repetition structures. Basically, we're talking about loops this week. So what is a loop? A loop is basically a set of statements that you will write in Python that might get repeated. It's like an if statement. There's a condition as to when it repeats and when it exits that repetition cycle. So let's talk about that. A lot of times you have to write code that will repeat the same thing over and over again. And what we don't want to do is duplicate our code again over and over, because if you do it once and you forget how many times there was a loop involved, you may forget to go back and look at the copy and pasted code that you had and edit them all. So we want to make sure that our code is neat and clean. Also, we talked about storage in the first week of this course, and we don't want to have Python files or any program files for that matter that are larger than what we really need them to be. We really want them to be as small as possible so the user doesn't download too much or waste too much disk space or storage space on their device. So, and then it's just more efficient for the computer to run it. Instead of loading in multiple lines of code, it loads in the same few lines of code and just iterates through them. So the first loop we're going to talk about is called a while loop. It basically has 2 parts. There's a condition. You test is something like an if statement. Is there a certain condition being met or not? And if it is, you may go through the loop, and if not, you'll probably exit out of the loop. The format of that looks like this: while condition, colon, just like your if statement. You had if condition with a colon before. This is a while loop, so it's while whatever your condition of you're testing for is, a colon, and then your statements that'll be executed while that condition is true. And your statements, again, like your if statement, are tabbed in a little bit. And as you start to type this in the Python editor, it will tab in for you automatically. On a flowchart, it looks a lot like this. You have a while loop, you have your condition. Just like your if, the condition is a diamond. If it's true, some statements are executed, and it goes back to the top of the diamond to restart. And then it keeps going. Now, this will keep repeating throughout this process until one of your statements sets your condition to be false. So part of the loop is not just what do you want it to repeat, but also potentially changing something for when you want it to exit the loop. Why do you want it to repeat? It depends on what you're doing, of course, but you only want it to repeat so many times. Maybe you're doing a countdown timer from 10 down to 0. Once you hit 0, you want that to end, so you set a condition that says, until you reach 0, keep counting down. Keep printing a number one smaller than the one before it. That kind of situation is what we're looking at. So in order for the loop to actually stop looping and exiting out, we need to set something that makes that condition false. What this means is that a while loop is what we call a pretest loop. And by that we mean that you test first before you get into the loop. And then once you're in the loop, you have to set a condition that exits out. Because again, when you're done with those statements, your loop will go, your process will go back to the top of that loop. So let's just say we're doing something for entering sales figures and maybe figuring out a commission rate. And let's say we want to do that for every one of the salespeople that we have. This flowchart shows you we're going to start the program, and our conditional says, do we want to keep going, keep looping around this and figuring out more? And if that equals yes, then we want to keep going. And if it doesn't, then we'll just end out of there. But before we get to that, we need to set that variable, that test for that, to equal what will actually make us enter the loop. So if we forget this first step up here to assign the y to keep going, so keep underscore going equals single quote y, if that's not set, then when we hit this loop, it's going to go right through the loop and not even bother, because that won't be true. So we need to make sure that before you enter your loop sequence, because this is a pretest loop, it tests before it enters a loop, then we must set whatever the test is to be true so that we can actually get into that loop. In and of themselves, if we do not set a condition inside our statements to exit that loop, then we will effectively have a bigger problem down the road, in which case we'll have what's called an infinite loop. It never actually leaves the loop. Let's practice one right now, and we'll see how this kind of comes about here. So we'll find my Python shell. We'll bring this over here. And we will create a new file. And we're not going to get too hard into this, but let's say we just want to go through and make a simple counter. We'll say, we'll set a variable first. We'll say counter equals 0. And let's just say we want to count up from 1 to 10. We will say while counter is less than 10, colon, there's our condition. When I press enter, I get tabbed over. We want to print whatever the value of counter is. Now, we also want to at some point leave the counter, leave this loop. So in order to count up, we need to say counter equals counter plus 1. So basically, when we enter this loop, counter is going to be assigned 0. When we go through each time, counter will increment by a value of 1. So let's just shrink these windows up a little bit so we can see what we're doing. I'll save this. We'll call this week 4. And I'm going to run this. And when we run this, we see that we start at 0. Just like our code says, we start at 0. While the counter is less than 10, well, 0 the first time through is definitely less than 10. It's going to print the counter. The value is 0 at that point. Then it's going to increment counter by 1. And at the end of that, it says I have nothing left to do. Let's go back up to the while loop. Is the counter less than 10? Well, at this point, it's now 1. So yes, it's less than 10. And we'll keep going. And it keeps doing that. And as we go through each time, it goes from 1 to 2 to 3. And when we hit 10, here's the interesting thing. When we hit 10, is counter less than 10? No, it's equal to 10. Well, if I wanted to count from 1 to 10, what now? Well, I'm starting with a 0, so that's something wrong. Let's start with this. Let's say counter equals 1. Now we can count from 1 to 10. But again, if counter is less than 10, when it hits 10, it won't actually print 10 out. So we say if counter is less than or equal to 10 to make sure we have our 1 to 10 inclusive. So now when I run this, now we get our 1 to 10. In a similar way, we can do this a little backwards, and we could say we can count backwards from 10 down to 1. And why don't we say on a different scale here, let's just say if we're counting from 10 to 1, we want to print the 1. We don't want to print the 0, let's say. While counter equals 0, equals for test for logic, we're going to print counter, but instead of saying +1, we're going to say -1. And then maybe when we're all done, maybe it's a rocket countdown. So we can say at the end, we can say print blast off. I'll save that. And again, what's the expectation here? We're going to start at 10. We're going to print the value of counter, 10, 9, 8, 7, 6, 5, and keep taking 1 away every time I go through the loop until counter equals 0. When counter equals 0, we're going to exit the loop and print blast off 1 time. Let's see how this runs. It does not run right at all. What am I missing here? Counter equals 0 is not what we're looking for. We want while counter is greater than or equal to 0. And this is where your logic comes in, and you need to understand all of your Boolean operators here. If counter equals 0, then we'll go in this loop. But that never equaled 0 because, again, in the beginning, we never set our initial value. Again, we're a pre-test kind of loop. So we have to pass the test the first time through. So we definitely want it to be greater than 0 to get into the loop, but once we equal 0, we want to get out. And actually, do we want greater than or equal to 0 then at that point? No, we don't. Because if it equals 0, we do not want to print the 0. So we actually want while counter is greater than 0. Does that make sense to everybody? Because when we get to 1, we run through one more time, we're going to take 1 away, we'll have a 0. When counter is equal to 0, it is certainly not greater than 0. I will save this, and now we'll run this, and we'll see what happens. We should now this time get our 10, 9, 8 down to 1, and then blast off 1 time. That's what a simple while loop looks like. Again, make sure that you set your variable ahead of time, whatever your test condition is, and then make sure you do something after your loop changes or after you've done enough iterations of your loop so that you can actually exit the loop at the right time and print things only the number of times that you actually want. So that would be a while loop. The loop will continue while the condition is met. The other kind of loop we're going to talk about this week is called a for loop. And it's a very similar kind of fashion, only instead of based on some kind of Boolean test, I mean, it's still a Boolean test, there's still a condition. This is really, it's more of a counting loop. So a for statement looks very similar. You say for, there's some kind of conditions about counting, a colon, and then some statements. It's designed, well, a while loop goes off a Boolean test. So you can keep iterating something until a certain condition is met, like an if. The for loop is really about counting values. So if you know you have a finite amount, or if you have a value in a variable and you can count up to that variable or down from that variable, or something sequentially, that's where for loop comes into play. So basically, so you have a list of numbers. Let's just say for a very simple, we're going to count to 5 instead of 10 this time. For a for loop, that would look a little differently. We would have for, and then we have a variable, in this case number, in, and then these square brackets mean we have a set of values. So for the numbers in this range, 1, 2, 3, 4, and 5, keep doing this until you're out of numbers, basically. So it looks kind of something like this. Let's get our shell back up here. Let's get our empty document here, and we'll do... and actually, what's really interesting about this, aside from initializing our variables, which I will accept, make an exception for loops, because a lot of times you just want one on the fly, but I still would like those to make sense. We can sit here and just say, for loop test, and we're going to say for value in, and let's just do what the exercise shows us here. For value in 1 through 5, put our colon, press enter, and we're tabbed in. We'll say print value. Okay? And if I save this and run this, the expected behavior is that we will print 1 through 5. I would hope that would seem to make sense to everybody. And there we are, 1 through 5. We have printed all the values in here. Okay, and there's other things we can do with this. An easier way of doing this is we can use what's called the range function. And a range says for value in range, let's do this. Let's leave that there. Let's try this a different way. For value in range, and then once you're in range, you have a parentheses. And now, if you look at our help here, we have stop, range stop. So that's our stopping value. In the case of the first one, it was 5. We could also choose a start value and a step value. I'll get into all of these. Let's start with the simplest. For range in 5, print value. And I'm going to throw a print statement in here first and just say range for loop, just to give us a little separation here. So we'll have a for loop list that will print 1 to 5, and then we'll have a range. You use the range function here. So we'll hit save here, and what we should get is a count up from 1 to 5 using 2 different methodologies in the for loop. But as you'll quickly see, here's our code. For value in gives us 1, 2, 3, 4, 5. But for our range loop, it starts with 0 and goes to 4. But why is the 5 not inclusive? Well, that's one of those fun things about using the range. And the range function has this, I won't call it a limitation because it's there for a reason, but it's not inclusive. Also, why did we start with 0? In any loop process, in almost every programming language that, at least the modern programming languages that I'm aware of, your first instance of something, whether it's an array of values or whether it's a loop, is always going to be a 0. Computers don't start counting at 1, they start counting at 0. So if we say loop this thing 5 times and we don't give it a starting value, by default it starts with a 0. So we have 0, 1, 2, 3, and 4. Well, we've done it 5 times. We just started with the wrong number, so to speak. So to talk about this here, really, the range function makes it a little easier to write these list of values, especially if you have a long list, right? We only did 1 through 5. If we were doing 100 or 1,000 or 1,000,000, that would be seriously an issue, and we wouldn't want to type all that. It would take forever. Kind of the idea of programming is to type less, and the idea of loops is certainly to type less. So the range gives us that ability. So again, as I said before, you can use 1 argument, 2 arguments, or 3 arguments. We used 1 here, and we got that result. I'm going to kind of just get this out of the way just for simplicity. So we did this, okay, and we got 1, 2, 3, and 4. Now let's try this 1, 5. And the 1 will be our starting value. And when we do this, and I run this, you see we get 1, 2, 3, and 4. Well, why is it not 4? Because I still said it does not include the last number. So a characteristic of using the range function, when you use range, you always need to go 1 higher than the number you want. If I want this to go from 1 to 5, I need to actually specify 1 to 6, because again, that last number in the range is not included. I'm going up to that, but not including that. So if I want to count from 1 to 5, I need to say range 1, 6. And again, I'll run this, and now you'll see we have 1, 2, 3, 4, and 5. Similarly, we can say, if we wanted to do 1 to 10, like we did for our for loop, we have to say 11. We have to go from 1 to 11. And again, I'll save this just to show it one more time. And now you see the 1 through 10, even though our code does say here 1, 11. Because again, 1 is our starting number, 11 is our ending number, but the 1 right before that. It's the last one, not inclusive. Lastly, I did say there's a third argument, and that is what we call the step value. What is a step value? That's how much we want to go up or down by. So, if we wanted to say 1 through 10, Nope, let's go the other way around. We can say we want to start at 10 and go down to 0, and we want to count by -1. That's the way we're going to count, by -1. So this, in theory, should replicate what we did before of our 10, 9, 8, 7, 6, 5 down to 1. And there you have it. And again, we were counting up before, and we said we don't want to include, the last number is not included. So again, I did not want to print the 0. What's the 1 right before 0 in this iteration? Well, when we're counting backwards, that would be 1. And that's how we get this. So again, if we just wanted to, finish this the way we had it from before, there would be our simple countdown. How about if we wanted to count a different way? We did -1 here. How about we count from 1 to 20, but maybe we don't want to count by 1s, we want to count by 2s. 2, 4, 6, 8, 10. That would look like this. And again, the range, the first argument, is going to be our starting point. The second argument is going to be our ending point, but again, non-inclusive. And the last one will be how much we're going up by. So again, if we're not inclusive here, perhaps we want to say 1 to 21. Let's save and run that. And I said, haha, we started at 1. Perhaps I want to start at 2 then. We'll make this a little more what we're looking for. 2, 4, 6, 8, 10, etc., etc. Interestingly enough, had I started with 0 and ended at 22, what do you think? With the 22 in there, will it count? We did say it's not inclusive. So what will this one look like? Starting at 0, which is not what we want, 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. 20 is what we want. Why don't we get 21? Well, because we're counting by 2s. Why don't we get the 22? Well, because we didn't want that. That's not what we did want. We didn't want that, and that's why we set it at that value. In fact, at this point, 21 or 22 as our ending value, since it's not inclusive and we're counting by 2s, will produce the same result. So, write a program that counts from 5 to 20 by 5s. You want to start at 5. That should be your first number. Go up from 5 from there. 5 plus 5 more is 10, 15, 20. The next one, well, we hit a limit of 21, so that's not what we want. So if we wanted to count by 5s up to 20, that would be our code. We could do the same thing with 100. But again, remember, we want something a little more. Basically, at this point, anywhere from 101 to 104 would be just satisfactory, actually even 105. This would be long, but let's watch it run. And that would be our code. So that's the for loop, and more specifically the range. Because again, the for loop is all about counting in a loop multiple times for a certain finite number of times. So in this, the target value for this is basically inside your loop. So let's say we want to count something. We want to have like a running subtotal maybe. We would have a variable on the outside that we start with. We count our way up to a certain, however many times we're doing something, and then when we hit that target, then we print out whatever. You could use it for a square root. You could use it for a factorial. Factorial being like a 5 exclamation point, which is 5 times 4 times 3 times 2 times 1. Anything you want to do, you can do inside that loop. So maybe you don't know how many times something's going to loop. That will happen sometimes when you're doing maybe a level. If you're video game programming, you don't know how many levels the user is going to play. They may run out on the first level. They may keep going for 12, 14, 20 levels. You don't know. And so you might just keep doing that. And if you're using a range function with that kind of a loop for various levels, then you want to make sure you don't have an ending limit. Otherwise, the game or whatever you're doing will end prematurely to that completing itself. Okay. You can also figure out that, we just saw we can do a series of numbers. We just did this one, counting from 10 down to 0 by -1. So again, this prints out, this range would be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. The 0 is not included. All right, let's work on this running total kind of idea. Let's kind of figure out, this is actually an example from your book. Let's bring up our shell. Let's bring up our code here. I am going to just pull up from the book. Let's see here. I think it's weight loss. Now let's look at exercise 8. Just a sum of numbers, right? So if you're following along in your book, the assignment says write a program that with a loop that asks users to enter a series of positive numbers. And those numbers should signal the end of a series when you type in a negative number. So yeah, let's work on that one. So let's start with our editor here. So again, if you're following along in the book, this would be exercise 4-8 on whatever page all the rest of the programming examples are on. I'm using the online version of the book, so I can't tell you that. Sorry. But here we go, exercise 4-8. So what do we need for this? Program that asks the user to enter a series of positive numbers. The user should add a negative number to end the series, and then all the positive numbers should be added up together when we're all done, which is display the sum. So let's figure out what we need for that. We would need, we need a test, right? If we're going through to do a running calculation, we don't know how many times we're running through. We will need a loop value. And let's assign that to 1. And let's just limit this to ints for right now, I think. If we need to display the sum when we're all done, we'll say, we'll just call this sum for right now, sum. And right now that's going to be equal to 0. We're going to set that right now. So we're going to need a loop, right? And that loop is going to what? We're going to loop to take input and add the sum. We are going to check for a negative number to exit the loop. Pretty simple. All right, so what will this look like? We are going to say while loop value is what? We need a negative number, it says. The book says the user should enter a negative number to end the series. So a negative number would be less than 0. So we want to do this while it's greater than 0, or perhaps even greater than or equal to 0, because a negative number implies not 0. So if the loop value is, just less than 0, not equal to 0, because we can enter 0 and add 0 to our sum. It won't do anything, but so if we're looking for a negative number, we want to make sure that, we're looking for a negative number to end. Anything that's not negative would be greater than or equal to 0. I had it right the first time. So our loop, we're going to enter our loop when we equal 0 or anything higher than 0. All right, we're set now. So what are we going to do here? We're going to say, we have one more variable up here. user number. And we'll set that equal to 0 for right now, just to initialize it. All right, we're going to say user number will be equal to, we'll make this an int, I said, input, enter a positive number. Should make this program just a little wider here. To add. Negative number to quit. Seems to be right. We'll give a space in there. That would be that. We'll close off of our parentheses for our int. All that flashed really nicely, so that should be good. Now, this will give us a number. Now, we need to combine our if statement here, because the first thing we need to do is make sure we don't add our negative number, right? So, if, do we really need if? Because we're not going in here if we are negative. So let's say our sum is now going to be equal to whatever our sum was before, plus the user number, which I appear to have spelled wrong over here. So if we've got this all right, our sum starts at 0. Our first time through, we're entering a number, and then we're adding that to our sum, which starts off as 0, but quickly adds things to it. Okay? What else are we doing? I think that's it. We'll go through the loop again. And if a negative number is entered, then we'll end the loop. And if the of a positive number is entered, then we'll just keep going through this loop. So let's see here. Print the sum of your numbers is, and then since this is simply an int, we can just add that in there. Nope, we're using sum, not user number. Does that look good? That looks good to me. So again, we have a loop value that we're starting as a positive number, so we can make sure that we enter our loop. We have a user number, which is just what we're going to input. And we have a sum, which will be our running total for this. First time through, our loop value is positive, so we will enter this. Somebody will enter a number. If they enter a negative number, found a loophole here. If they enter a negative number, we are already in here. So we'll have to see what happens here. We'll see what happens here. I think we may have to be modifying this, but let's go with this for right now, and we'll debug it when we're done. So we'll save this, and we shall run it. Enter a positive number to add, negative number to quit. How about I shrink this up a little bit so we're not confused by everything else on the screen there. Let's start with 2. Enter a positive number to add, negative number to quit. Let's say 2 more. That should give us 4. And now let's just enter a negative number. Anything will work to exit out of this loop. We didn't exit out of the loop. How come? What's going on? Well, let's see. First of all, we are now, folks, in an infinite loop. I can enter anything not almost anything I want to here, because I put a space in there. All right. Let's figure out where we went wrong here, shall we? Well, first things foremost, our user number is actually the number we're looking for here. Loop value never changes. We're looking for user number. I put too many variables in here, overthinking this on the fly. So let's get rid of this. We don't need loop value because we're going to base everything off the user number. And we'll keep that at 0 because we don't want to affect our sum. It's going to change as soon as we enter the loop, but that's okay. So now, let's see what happens with this one. We might still need to change a few things here. So we'll start with a 2. Enter our first positive number. There's a 2. We'll enter it again. Now our sum should be 4. We're going to enter a negative number to get out of this loop. And that worked. But why is our sum wrong? Well, let's look what happens each time through this loop. First time through this loop, our user number is 0. So we can definitely enter the loop because it's not negative. Then we assign user number to 2, and our sum becomes sum plus the user number. So we have 2. Next time through, our last number was 2. That's fine, we're going to keep entering. Now we have another input. We said 2 the second time. So now our sum should now equal to the previous sum, which was 2, plus 2 more, and that is 4. Now we run through it one more time. We enter -8. The user number should be negative. Where did we go wrong? Well, perhaps before we go into the sum, we should make sure, we'll tab in here to make sure we're in the same level, that if the number is greater than 0, then we will add the sum. And if not, we just won't. And we don't need an else in this case because we just don't have any conditions afterwards. We don't need any special steps. We just need it to not execute if it's not. So, and in fact, if it's 0, we don't need to enter that either. So we don't even need greater than or equal to 0. So let's try this now. Invalid syntax where? I forgot my colon. Run it one more time. Enter a positive number to add. 2. Number, because I want user number. Thank you. This is where sitting in front of a real class would be great, because when I start bringing my brain at 20 miles an hour, you guys can give me feedback. A little hard when you're just by yourself. One last time. Let's save this and run it. All right. Positive number to add. The first one is 2. We'll do it again. 2. We should have a sum of 4 right now, so let's just throw any negative number out there. And our sum is now 4, because we didn't add it up going through the loop the next time around. So this is where, and I know a lot of you tried real hard for the last lab, sometimes you need to put more than one value in to figure out exactly does it work for all values that you're talking about. Let's try this again. 4, 3, 2, and 1 should add up to 10, right? So let's say 4, 3, 2, 1, and negative whatever that is. And the sum of our numbers is in fact 10. What if we want a running sum as we go? Okay. That would be, once we add and change the sum, we could say here, print your current total is. And we can put sum here. And we'll just leave this output for right now. And again, this will be happening inside of our loop, inside of our if we were actually adding a positive value to it. So again, we'll just try the 4, 3, 2, 1 thing. 4, your current total is 4. 3, your current total is 7. 2, your current total is 9. 1, and in fact, I can keep doing this all day. Let's say 10. Now we have 20. Let's add 80 more to it. Now we have 100. That's a good grade. I like that one. Let's stop there. And enter some kind of negative number. And our sum of all of our numbers is 10. That is how you start setting conditions for loops. And you can see where your first time through you can overthink this. I was asked a bunch of times, why? Why do we have to initialize variables at the top of our programs? This is one of those reasons why. So you start realizing what you need and you don't overthink it. I actually overthink it a little bit, but it's to get yourself thinking about what you're going to need, what you're going to use going forward. Let's keep going. To make life easier, there is actually some neat little operators that we can use. The book calls them augmented assistant operators. That's fine. They are basically, in addition to your plus, minus, multiplication, float division, that kind of stuff, there's actually what we call shortcut operators, if you will. The plus equals, the minus equals, and similarly the multiplication equals, division equals, and mod equals. And what this does is say, in our code here where we had, our sum equaled our sum plus something else, this would be a shortcut way of writing this code. So instead of using sum equals sum plus user number, we can actually write this as sum plus equals user number. And I will comment this out over here just because I want the concept to be, actually we'll just do this. We'll say, because this, oops, same as that. Sum plus equal user number is the same as writing sum equals sum plus the user number. When you're doing incremental totals and running totals, this is just, again, one more way. We want our code to take up less bytes, right? And if we have wonderful variable names, like Professor wants you to have, and have these long underscored names, that takes up more characters. It helps other coders understand what you did, but if we have to write that out multiple times, it just takes up more bytes. So again, just to prove and show you that sum equals sum plus user number is the same as sum plus equal user number, we're going to run this one more time. And we'll do our 4, 3, 2, 1. Just add up to 10. 4, current total is 4. 3, look at that, current total is 7, just like before. So again, it's I'll call it a shortcut. The book calls it an augmented assignment operator. This plus equals. Similarly, you could do the same thing with plus minus, or sorry, minus equals, just to help you out. So again, this would add 1 to the value of running total. I think our code here showed it pretty well. As we keep our running total going here and add our user number, that's kind of what things look like. Sentinels. What is a sentinel? If you're a Marvel fan, it means something completely different than what we'll talk about here. The sentinel basically is something, some value that will help your users exit the loop. We actually had a sentinel here in using our negative numbers. Once we set this flag to negative, this number to negative, we know that will help us exit the loop. It might be something different. Hey, we're going to keep doing this until the running total gets so high. That kind of thing. That's all it is. What you do want to make sure, though, it's a key thing here, is make sure your sentinels are distinctive so you don't make them similar to a regular variable. Again, let's not use the same names, all caps for a named constant and all lowercase for, that happened a lot with the cookie recipe. Somebody had capital cookies. In fact, many of you had the word cookies capital for the number of cookies in the recipe batch, but then used lowercase cookies as a variable, which is technically correct, just not very descriptive. And when you start getting to more complex concepts like loops, you want to make sure your variables are distinctive enough and your constants are distinctive enough so that we understand. One last thing, too, is you can use things like a negative number. You could use y or n for yes or no, and you could even use a blank line. If you use a blank line and your program is expecting an int value, just make sure you look for that. Remember, though, anything typed in as an input becomes a string. So if we were to use a blank line in this scenario here of entering our positive numbers, instead of saying negative number, if we wanted a blank line, then we would not be able to cast this right away. If we said press enter to quit, we would need to change this up just a little bit. So that would be fine. And then we would do something completely different and say we'd have to typecast this, right? And then up here, we would have to ask actually if this was an integer or if it was some kind of numerical value as opposed to a string. And if we're setting this up here as a 0, then that complicates things immensely. Can you use an empty line? Absolutely. You check for a string that is empty quotes, kind of like you would do with the sep or with the end character in a print statement if you wanted to make sure there was no character there. So again, how does this look? Well, you set your running total, book says accumulator, fine, to 0. Is there a number to read? Yep, there is. Read the next number, keep adding it. We just did this. If there isn't another number to read, or if you see a negative number, then it goes through and exits and does whatever it does after that loop is finished. One thing to note is that computers just take data and they try to work with it. As you saw before, I did not, in one of my outputs there, I was going too fast and I pressed enter twice and got a type error while I was running the program. Wasn't a syntax error because my code syntax was correct, but the data that went in was not what was expected. There was no value there. And so casting an empty string to an int caused an error because the type was not the same as it was expecting. It was not an integer. This is called very, very affectionately among programmers, garbage in, garbage out. If your users put in something that is unexpected, then you will get something unexpected as your program runs. And I know a few of you for the last lab tried to do some error correction, and a couple of you did it to really great effect, and that was fantastic. We're still not there yet. I'm not asking for that for this lab, but understand that that's how that works. Now, why are we saying this? Well, because that's what loops can be used for, actually. We can see if our input is correct or not correct. And there are some great examples in the book. And if you want, set up some office hours with me and we can go over that. But basically you go through and you say, hey, is this input what we expected? Was it a positive number? Was it a number at all? Was it a string of characters? If it was what we expected, great, keep going. If it wasn't, hey, keep repeating that input statement. Maybe throw an error message out there and say, hey, you didn't do this right. That's not what we were looking for. So do it again, please. Okay. So take the input. Is the input what we were expecting? If it's, or in this case, was it bad? If it was not in the range we're looking for, display the error message and get the input again. Let's try this here. Let's go through test for good data. Let's say we are doing something that involves grades. They should be what? Between 0 and 100, right? And that's what a normal grade should be. So we want to make a loop to make sure grade value is a valid number. And valid in our case would be between 0 and 100. So what you might do is you might say we'll need a variable called score. And I'm not going to initialize it at this point. We'll just say score is equal to int input enter a test score. And in fact, you know what? Let's do this. And you can work along with me, maybe, if I can make mine shrunken up enough. And you can work on this, if you'd like, with me. Enter a test score. Okay. We'll close that off. So that should be good. And then we'll validate the input. And we'll say, learn how to spell, Mr. Craver. We will say, while score that we just got inputted is less than 0 or score greater than 100, and we'll throw our colon in there for our condition, print error, the score cannot, oh, we'll just say this, we'll just keep this simple. The score must be between 0 and 100. Then we're going to take the input again. Okay. We can be a little cheeky here and say enter a correct score. And let's just be nice about our inputs here. All right. So that's what we're looking at. It's the same as in the PowerPoint here. We'll say your score was, just thought about doing this on the fly. Your score was ... score. That should do it. Let's see if that runs for us. Enter test score. We'll just say 99. Your score was 99. Great. Let's run this again. And I'll say our score this time was 110. Who wouldn't want that? Oh, the score must be between 0 and 100. Well, let's try negative 50. Nope, the score must be between 0 and 100. 999. And this will keep going until somebody gets the correct input type in there. I'll say 0. Your score was 0. Now, this might be some of the error checking you would do perhaps on our running total that we had before for all of our numbers. Similar kind of situation. So again, just make this really big here. What we're doing is taking an input, because our input, we need to have our variable, our test condition variable for our while loop, right? We need to have it set before we go into this loop. Is the score invalid in this case? Yes, it is if it's lower than 0 or greater than 100. So we'll put our error message out there, and we'll keep taking the input. And we'll keep taking this input until it's correct. If you want to start error checking on your lab assignments, that will be great. At this point in time, or at least until I say otherwise, there won't be any extra credit for it. But if you want to practice that, I'm all for it. You might want to consider that on your programming projects, making sure errors are validated. But definitely if you're having a problem doing it, if it's throwing off your lab assignments, drop it unless it's a requirement, and you'll know by the requirements that we list in Blackboard. But if you're going to do it, make it the last thing you do. Make sure you have a working program first, and then go after validating your inputs. Nested loops. What is a nested loop? Well, basically, it's a loop inside another loop. We saw that with our if statements last week, and you'll have one of those to work on in your labs this week. If this, then if this, then if this, or else if, depending, and you can go, if this, else if this statement, and if statement, you can keep going with nesting. A nested loop is kind of the same kind of thing, right? Is there another value you want to do? Yes. Assign the next value. Is there another value? Yes. Assign the next value. We can just keep looping this over and over and over again. And the inner loop obviously will go faster and faster. The book will tell you that, think about a nested loop like a clock, right? You have a second hand that goes around and around and around and around and around every minute. The minute goes around much slower, and the hour goes around even slower. So you will do 12 loops of an hour. And for each one of those loops that an hour hand will make, your minute hand will make 60. And for each one of those ticks, one of those 60s that your minute hand makes, your second hand will make 60 more. That's kind of, how you were keeping score or keeping time that way. If you wanted to print off every single second of the day, you would print off a nested loop kind of thing. Let's look at one really fast. If you are familiar with Excel, Excel is a spreadsheet program, or Google Sheets for that matter. I guess we could talk about that. Across the top, you have columns, and those columns are A, B, C. And then going down, you have rows, 1, 2, 3, 4, 5. So, and to name a cell, the first one is called A1. The next column over is B. So you have B1 if you're in the same row, C1. Under A, as you go down, you'll have A1, 2, 3, 4, 5, and keep going. Let's just write how that naming convention looks. So again, I'm not going to do a lot of variables here. We'll just say this is nested loop example. We're only going to do variables for the loops at this point. So we won't name the loops. We're going to say, we're going to talk about rows and columns. let's do rows first. For row in, and let's just keep this simple, and I'll say A, B, C, colon. And then for each row in those columns, we will have, I guess those are columns, aren't they? That's all right. We'll have a column in a range, let's see, we'll say a range from, let's just do 1 to 5. And it was going to increment by 1, so that's fine. If we're doing 1 to 5, though, we want 6. And we can say print, well, since we're calling these row col, we'll say row col. In between each one, I want a tab. Did I press enter by accident? Print row col, we're going to put a tab in there. Tab, and then we'll say, because I don't want anything else, we'll say sep equals that. Because I don't want to separate the row and column values, but I do want to print a tab after row and column print. And we'll say end is going to be equal to do we want a new one? Let's leave it blank for right now. No, we'll leave it blank here because we're going to print more than one of those per. Okay, yeah, this will work. Now at this level, and you see how my tabs are here, we're gonna print our new line. Now, what is this? Why did I think so hard on that? What I want to do is say for every A, I want to print A1, tab A2, tab A3, tab A4, tab A5, 1 through 5. Then, I probably did this backwards from what I'm trying to think of, but you'll get the idea here. Then I want to print my new line and go to the next one. Then I want to start with B, 1, 2, 3, 4, 5. And if I run this, sure, I'll save it. That's fine. And we'll get it that way. Now, I actually did this a little backwards, so why don't we try to do this way. So that should look right. So we're going to start with our columns. Well, still the wrong variables, but why do I think that's still wrong? It's telling me my tabs are off. That should be better. There we go. And that's more what I was looking for, because in Excel, that's what it would look like. A is down the left, B is the next column, C is the next column. So I did have that backwards when I was thinking about it. But there you go. That's how you would print a nested loop. It's going to start with, for each column, we're going to print out a 1 through 6. For each row, we're going to print out A, B, C. So we're going to start with row A, column 1, the first time around. Then we're going to loop back B. We're still on column 1. Then we're going to loop back again C. And now we're done. So we're going to print the new line. Since the new line is lined up with my inside 4, after the new line, it comes back up to the top for col. And now we're going to say col is now equal to 2. So we're going to say print A2 and a tab, and then B2 and then a tab, and then C through it. And that's how we get what we get here. Nested loops, one inside the other. You will find you will have a lab in the future that talks about that. So, and again, the total number of iterations, if you're trying to figure out how many iterations you're going to have, would be the number in the inner times the number in the outer. So in our code here, we had 3 values here and 5 values here. So that should be a total of 15 iterations through our loop. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 iterations through that loop. At least total iterations through the entire loop. Things to know. All right, what did we cover today? We covered repetition structures, okay? Condition-controlled loops, those are your while loops. Count-controlled loops, those are your for loops. We talked about how to nest them inside each other. Infinite loops. Make sure you set a sentinel so you can break out of something, or make sure you're counting your range correctly, or you're incrementing your variables inside your statements inside that loop correctly, so it will eventually break out if your test condition is such. Calculating writing total, same kind of concept there. We talked about our shortcut symbols, if you will, for operations. The plus equals and the minus equals will be very important. And do you have to use them? No. Do they make your code crisper and cleaner? Yes. If I say there's a requirement you must use the augmented operators, then yes, you will need to use those instead. So watch the system requirements very carefully. Um, that's it for week 4. Don't forget, for week 4, you have 3 programming projects as well as the questions. Only 1 reading assignment, but please plan your week accordingly and make sure that you keep time in mind. I know you have other classes and other things going on, but there will be a lot more assignments coming, and this is just the start of it. I hope you learned a lot. If you have any questions, as usual, feel free to reach out via email or in the discussion forums. Thanks.